Hello, I'm Sam. Welcome to Web3 Unity SDK Examples. Moralis offers the Web3 Unity SDK. Let's break that down. Moralis provides a single workflow for building high-performance dapps. It's fully compatible with your favorite Web3 tools and services. Unity's flexible platform offers incredible possibilities for creating real-time solutions, including games. The Web3 Unity SDK brings the power of Moralis to your Unity projects.
Hi, my name's Sam. I'm a Unity certified developer at Moralis. I have over 20 years game dev experience and more than 10 years experience as a digital nomad. I love spending time in nature and practicing sports, as well as drawing, painting, and making music.
Let's take a look at the generations in web. We're currently departing Web 2 and experiencing more and more Web 3 experiences powered by the blockchain. Now, it's not a perfect analogy, but let's look at the generations in games. Each day, we're seeing more and more Web 3 experiences. And with the power of middleware technologies like Unity as a game engine and Moralis to empower the Web 3 aspects of our game projects, we're able to move from idea to market faster. Moralis includes complete learning resources, documentation, YouTube videos, and example projects like this one. The Web3 Unity SDK Examples project is a great way to learn more about the features within. Before moving forward, if you want to learn more about the Moralis SDK itself, click the link above. And learn more about authentication with the Web3 Unity SDK by clicking the link above. Now let's take a deeper look. The Web3 Unity SDK Examples project is available on the Moralis GitHub. To get started, open up the README file inside Unity. Follow the steps inside the README. And enjoy the sample project and the sample project code. A recommended approach for these examples is to find a scene that talks about the topic of interest, run the scene inside Unity and play with the UI on screen, and then for a deeper dive, take a look at the code inside each example. You can import this and experiment with it and bring it into your own projects. The main entry point inside Unity is the Moralis object. It centralizes key functionality and it contains several subsystems, including the Moralis client, the Web3 client, the Web3 API, and the Solana API. And our examples project follows a similar structure. Inside the folder for each of the examples, you'll see a few key files. First, there's the scene itself. That's the one you want to double-click to run inside Unity and get started understanding the scope and how to experiment with the different examples themselves. Then there's the script powering that, which is where we're going to focus to look at the key features that you're going to want to look at, experiment with, eventually port into your own project. You'll also find a UI script in each of them. You can ignore it for most use cases, but it's what powers the UI and does Unity-specific stuff. The Examples project handles authentication automatically. Now, not all of the SDK functionality needs authorization, but for simplicity's sake, each of these example scenes does. Once you log in once in any of the example scenes, that session will persist today, tomorrow, and whenever you come back to the project. You can always log out manually using the on-screen UI. Now let's open up Unity and take a look at the Web3 Unity SDK examples. So that we can see the screen better, I'm going to lower the opacity a bit. Here we are inside Unity and we've installed the Moralis Web3 Unity SDK examples folder shown in the project. We'll get started by looking at the README that has some helpful info. We can find that here in the Moralis menu under Open README. I'm going to pin that here for ease of use. We see here we have information about Moralis, including some helpful links, also about this particular examples project, and then getting started. In the getting started, I've already done step 1 and step 2, which are specific to running any project within the Moralis and Unity SDK setup. So you can see some other videos about how to do that, but it's pretty self-explanatory there. Then what we want to do specific for this project here is update the build settings. So there's a top menu item under Window at the top of Unity for doing this, or you can just click here. There we go. What that does is it puts one of every scene into the build settings. That's useful for Unity. Anytime you have a multi-scene project like this, it's going to save us some steps there and just do that automatically. So now we're ready to move on, and you can adjust these windows any way that it works well for you. You might have your own preferences, but if not, you can use the one that we include here specifically for this example. So we're just going to click here, and we see that the Unity layout updates to be nice and large with the game window here at a 10:16. And finally here in step 5, you see we were able to open up any scene. You can click through right here to start with one of these scenes here, or freely browse around in the folders and choose the one that works best for you. Moralis examples. Okay, to take a look at this section, we're just going to open up the folder here, and we'll look at the very first example. So the structure for this folder and each of the folders for the examples is to have one scene, which we're going to open up. There's going to be a main script which has the same name. We're going to take a look at that to get the specifics for how the scene works. And then in each of these folders, there's an example UI script, and that's used to power the different buttons and the layout that just makes the Unity scene work. It's less interesting. You can ignore it for most of your learning of the Moralis itself. So I'll open up the example scene. Here, let's take a look at the structure of the hierarchy itself. For most scenes, we have a camera, lighting, and that canvas itself. It's going to be the same canvas used across all scenes because the UI is quite consistent. And we just, for simplicity's sake, put that under a world node there. Then in each scene, there is a game object named for the scene itself, and we're going to be able to click through to the code there. We'll start by running the scene, and then we'll take a look at the code, and we'll be able to do this for every example we go through. So here in this demo, we're using the query functionality. If you want to learn more about that, you can check out docs.moralis.io for more info. In each of the scenes, like you see at the top here, it gives you a little bit of info about how a couple of the popular methods that relate to this work. So here we're going to be able to create a custom object called hero, and we're going to be able to query that. The scene automatically runs the query itself and shows that down in the details below, but we're free to click any of these green buttons as we like. So I'm going to go ahead and query. It's calling the backend, and it's getting all the hero objects that persist for this particular game. Now, hero is a custom object, and I've created those two elements that are there. If I create another one, we use the create method, and then if I query again, we see we have a third option. If I delete one of them, it will delete one particular ID. I think it's just taking the newest one off the stack there, and then I'll query again. Now we have two, and I delete again. So this fits into Moralis as a way that you can do database-like functionality all from C# without any backend setup. It's really elegant. Let's take a look at how it works. To see the running code, we can stop the scene, click on that primary game object there, and then just double click on the script over here. And that's going to be an easy way in every scene for us to navigate directly. So here in one of the example scripts that's related to this particular scene, we're going to see we have a method that does creation, and a method that does query, and a method that does delete. So that corresponds to each of those main UIs that we saw. So let's step through each of them. Let's start with creation. So I mentioned that we have a custom object that we've defined in C# called hero. You can click into that to see exactly how it's composed. I'll give a quick preview here just by clicking in. So we extend Moralis object, and when we do a little bit of declaring some different properties and setting up the constructor there. This toString method here is just for the ease of use. I display text corresponding to the hero, so that's an optional aspect there that helps the UI render out what this particular object is. Back here looking at the create, this method is called on the Moralis object itself. So I call Moralis create, that gives me a hero. I'm able to set any of the public properties however I like them. Depends on the needs you have here, but you can imagine you could have a game progress that would store which level the character's gotten to. Here, this represents a hero in the game who's got some properties, including some inventory like leather armor, for example. Important part here is down at the bottom, you want to save that after you create it, and then that gets saved. Now to query, what we're able to do is call Moralis.query here, like in line 51. And what that's going to let us do is get all the heroes and then do query operations on top of it. So here I'm getting all the heroes that have a level of 15. Now, when I'm creating these for the demo's sake, they all have a level 15, but I was just showing you some of the syntax there. Then what I do is find all of these results and I return them as a list and I render them out to the UI. Finally, the Moralis delete here. What this does here is calls the delete async on that hero object and is able to delete it. So there we've seen how we create them, how we query them, and how we delete them. Let's run the scene one more time just to see. Again, we've got creating the hero, querying the hero, and deleting the hero. That's it. Now let's take a look at the live query operations. So here we can see that we've got a similar structure here where we have the scene itself, we have a script corresponding to the scene, and then we have the UI. As we said before, we like to ignore that one for the sake of these demonstrations. One additional piece of code here, we see that we've got a class for the callbacks. So let's take a look at the scene and run it and talk a little bit about how it works. So here we're doing live querying. So we're able to query the hero. We're able to create a new hero. And if I query again, we can see that there. And we're able to delete a hero. It's the same setup as the last scene, really the same end user experience. The only additional functionality is that we have these console traces here that are showing the operations as they happen. Now, the functionality we're about to show is not just about logging. This is just a simple way to demonstrate it. It lets you do a callback anytime these database or hero objects are being fetched from that database, anytime those operations happen. You could listen to all sorts of events. So let's take a look at how this scene is set up. So here we are in the live query scene. We see we've got one method here that does adding the subscription. This is the new part. We see we've got a Moralis create. That's identical to our last example scene. As with Moralis query and Moralis delete. Those are exactly as they occurred in the last demo. So really, let's look at this add subscription here. What we're able to do is create a new custom object. In this case, I've called it Moralis live query callbacks for hero. And inside that or outside here, as I'm showing, you can subscribe to different events that happen there. And all we're doing is every time we click that create button, this gets automatically called back and you can run any code there. So you can imagine in a more robust game project where you have a database that represents your character's progress throughout the game, you may want to have the UI or some aspect of the game respond after the user stores their progress through the game or loads it back up, right? So you'd be able to listen to these events. The key thing here is that we're going to add subscription here at the end. And just to be safe that we haven't added the subscription before, since this is a demo scene, I always remove the subscription and then add it. But I know that depends on how you're going to use that in your project. But it's the add subscription here that really does the work. So let's take a look inside the custom class and see how that's set up. So one of the important factors here is that we extend Moralis live query callbacks and we pass in the type, what we're going to be dealing with here, which is the hero object. Then really that's all you need to do, but I do have some comments in here just to show that these are all the different types of subscriptions that you can do. So we have connected, create, delete, enter, error, subscribed, and unsubscribed. So you as the developer can listen to any or all of those, either doing them inside the class here, if that works for you, or doing them outside the class here, which is what I've chosen to do for this example. Let's give it a run again. So we're able to create a hero, query that hero. We see that we've got 3 now. Delete, query again. We see that we've got 2 because the deletion properly happened. And the live query callbacks that are happening here are in the console window. That's it. Moralis client examples. Let's take a look at the Moralis client operations. So we'll open up the example folder here. We see that we've got the scene itself will load up, the example, and the UI script, which we will ignore as always. So I'm going to go ahead and run the client. Now, quite simply, what this scene does is every time you click Get Client, it just calls the Moralis Get Client call, and then it shows some of the info, not all of it, but some of the info inside the window here. Each time I call Get Client, it's just going to refresh that view. So the client object returns information about the session and the current game client that you're inside of, and a lot of the other operations take advantage of this under the hood, but for advanced use, you might want to get this client and do things with it. Let's take a look at the code for it. So here we are inside the script. We have one method here to do the get client, and then let's look at the actual execution of that code. What we do here is call Moralis get client. That returns just the client object. And then the rest of what we're seeing is really just about putting that in the UI. But you can see here you're able to call Moralis client dot and get at many different values underneath it. I'm just showing some of them here. Let's just run that again here. And again, we see that we're calling get client and we've got that info there in the UI. That's it. Moralis Cloud examples. Next, let's take a look at Moralis Cloud. Moralis Cloud lets us run operations which we declare in the cloud, and we run them from inside Unity. This gives you a lot of different options as a developer for which code you want to put onto the server for different reasons and run them from the cloud. You can check out docs.moralis.io for more information about how you would want to integrate this into your game projects. But let's take a look at what we actually do here to set it up. So we've got here the scene itself and the core file for the example code. And then you see we also have a cloud function script here, which we'll take a look at. So here the cloud functions text, this is just a local copy of what must be set up onto your server. So you can copy and paste these two methods and follow the instructions that's shown at the top of this page and have them set up inside your server running behind your Moralis project. I've already done that for this project, so I'll go back into Unity and go ahead and run. Here we are running the project. So in the top window here, we can see the server-side JavaScript that is running behind. That's just a reminder that we've got something called myMethod, which is just going to return some simple text. And then we've got myMethod2, which is going to add together a couple numbers. At the bottom of the screen, we can see the live return values coming from the server. So I'll click method 1, and at the bottom we see the result is indeed hello world. And we click call method 2, and we see that the addition of 10 and 20 actual equals 30. Click my method 2 here, and we see that the addition of 10 and 20 is indeed the result value of 30. We can also click this button here to open up the Moralis Cloud itself, which would let us copy and paste these values into it. You can do that as you evaluate the project on your own. Let's look at the code here from the C# side that makes this happen. And here we are inside the sample code itself. So we've got two methods. We've got the Moralis Cloud Run Async 1, which is called when we click that first button. What this does is it fetches the string result from running async, the myMethod1. That calls the backend, and if you have properly described the method during the setup that I mentioned, and that exists there, it will run it on the server and pass you back the value. Here inside run async 2, we're calling myMethod2. This one is a bit more complex. You can see that it needs two parameters. So you're able to put those two parameters together. In this case, we're adding 10 and 20 to return value 30. You can, as you're experimenting with these demos, you could change those values and see that they properly add together other values as well. So let's just run that one more time. You see that we've got myMethod1 running at the bottom, myMethod2 running at the bottom, and that's it. Moralis user examples. Next, let's take a look at Moralis user. Here we see that we've got the scene itself, we've got the core functionality. We'll take a look at both of those. So let's run the scene here. So we're able to get the Moralis user object back from the SDK by calling getUserAsync. You can see all sorts of info that comes back from that. Some of it may be directly useful into your game, but there's lots of stuff in there. Let's take a look at the code and see how this is set up. All right, here we are inside the code, and we can see we've got a method here for getUserAsync, and let's take a look at how that works. First, we just call on the core Moralis object itself, getUserAsync. That's an async operation, and that gives us back the Moralis user object. Then the rest of what we're looking at here is just putting that into the UI. But you can see that under the Moralis user, there's all sorts of different information that you may want to get that's useful for your game project. It includes the Moralis user auth data, which is a dictionary of information that you can parse through and get all sorts of data out. So this is a bit of setup just to put that into the UI. Let's run that scene again and see how it works. So here in that running scene, I'm able to get user each time. It's showing the same information every time, and it's reflecting who I am as the logged in user. And that's it. Solana API examples. Now let's take a look at the Solana example. So here in the folder of Solana API account, we've got the scene itself, as well as the main script to take a look at. Let's open up and run that scene. So here we're able to get robust account details about a specific address on the Solana that we care about. Here we can get the portfolio and get information about that. We can get the NFTs using the getNFTs method. And we can get the balance using the balance method. Now, each of these are all using the same address, and this is a public address that I found that is quite a busy and robust account. Because we're not performing any operations on them that require signing, we're able to get this information about any address we choose. Let's take a look at the code. Here we are in the code. Let's take a look over some of the key methods here. Because I had a lot of information coming back, I created something called the loop limit class that just lets me set, as I'm looping through the incoming results on the client side, how many do I want to get? This isn't an SDK feature. This is just something I created in the example project. So that's that loop limit that you see there. I have it set to 3. So when a list comes back with 10, 20, or 100 results, I just grab the first 3 for brevity in the UI. You can, of course, tweak that or get rid of it to get as many results as you want. The address that I used here, I store in this constants class. You can see more information about it if you click through to that. So first is the balance call. By calling Solana API account balance, we're able to get the balance information for any address on a specific network type. For get portfolio, we're able to get the full portfolio information for any address for a given network type. And for the get NFTs, we're able to get lots of different info about the NFTs for any address for a given network type. You can see the types of information that comes back, including what we loop through here is strongly typed in much of these cases, so you can dig into those classes and see more about what information is shown there. For the sake of the demo, I typically just show a very limited amount of info just as a demonstration and beginning point, but you can dig into there and get all the info that meets your needs for your game project. Let's go back and run it again. And again, we see that we've got the balance, the NFTs, and the portfolio. That's it. Web3 API examples. Now let's take a look at the Web3 API examples. So we're going to open up the folder there. You see we've got a couple different ones we can run here. The Web3 API account demo is going to be similar to what we've seen before with Solana. We're able to get information about the specific account address. Run contract function and storage are going to be quite different. So we're going to take a step through each of those. Let's start with the account. You can see we've got the scene itself as well as the monoscript that runs it. So let's go ahead and start. So here we're able to click through and get quite a bit of information about any address. Now this address that I chose, I just found a very popular and populated address available freely online. And you can see more information about that in the code comments. Because we're not doing any operations on this that require signing, we're able to get information about any public address that's out there. So you can see a bit of the method signatures information on the top, and then this is the live info coming back here. So that is get info from the native balance, and then we can get info here, which gives us all sorts of details about NFTs. And then we can get info here, which is going to give us information about tokens. You can scroll through and look at that data. Now let's take a look at the class behind it. So we can take a look through here. We see that I'm using the loop limit class. This is a custom class I've used just for the examples. This is to limit the amount of data I show in the text field, just so we don't have to scroll that UI text field forever. You can get rid of that, or you can tweak the values as you see fit. I'm just showing 3 results for some of these loops. So the first one here is getting the native balance. You see we were able to get the native balance for any one address we choose on the chain that we want to use there. So then we can step through here and see getting transactions. It's going to get us all the transactions, if they exist, returned as the transaction results list itself, and we're able to for each through that and give some information about it. There's lots of info you could get about the given transactions. I'm just showing the value there for an example. Next, let's take a look at getting the token balances, which is going to give us the balance information we're able to loop through for any address on the chain that we care about. And you can see I have a note to myself here. So I'm using a constant value for one popular address for this whole scene, which you can freely use or tweak if you want. If you wanted to get your own information, you would be able to access through the Moralis user and getting your own ETH address. So if you want to have a UI that shows the current logged in user's information, that's an easy way to fetch that. So then down here, we can see the token transfers as well. You can see we're digging into lots of information inside there that's available for us. Then we have the getting the NFT information here. So in getting back the owner collection, being able to iterate on that. And getting information about NFT transfers. You can see that we're able to go through and get each of the transfer objects. You can dig in and see exactly what information is inside those classes, so that for the needs of your own game, you can get the info that you want. Down here is getting NFTs for a given contract. So that's by address, token address, and then the chain list itself that you want to get that on. Let's run the example again and take a look at it. Here's that running scene again. And up at the top here, we've got a drop down. I didn't mention this previously, but in quite a few of the scenes where the API supports different chains, you're able to choose which chain you want from the chain list. So by choosing that, it'll refresh the UI here. Because I chose an address that has quite robust information on the ETH chain, that's the one that I have pre-selected there for you. Then you can click through again. Here's the getting info for native stuff, for NFT information, and getting token information. That's it. Now let's take a look at the run contract function. So opening up the scene there, you can see the folder structure. We have the familiar scene itself. We have the main monoscript behind it. And then we also have this run contract function. So this is one of the example scenes that does require some setup ahead of time. What I've done ahead of recording this video is already set up a contract and deployed it. And this project points to that. You can take advantage of that by just running the scene as is. If you want to dig in and understand how you would create your own custom contract information and be able to pull that in, you can take a look at that URL there. With that backend properly set up and configured, here within the client, we're able to call a function there. You can see that we're getting and showing in the text field the full result of that, which in this case is just a little JSON blob. But you can imagine in more robust examples, you'd be able to return whatever type of data you want from a contract there. So each time I click the run contract, it's going and fetching that quite quickly and giving us the full info here, which is more info that we need for this specific demo, but it's just to demonstrate the types of things that could come back. That's a JSON blob. Let's take a look at the C# for this. So here in the code, up at the top comment, you can see I point to the docs.moralis.io for more information. This is a particular topic that you'd want to dig in and do a bit of reading about because there is some setup and subtlety to how you're able to use this. Having all that been set up already, let's just take a look at the code here. So here in the run contract example method, what I'm able to do is run the contract. Let me get down to it here. We're able to run the contract function here. So what we're passing in here is the address itself, the name of the function, the information that comes along, the DTO, and then what chain to run on. So if we just scroll up here, I can look at some of that setup info. So as with running smart contracts in many different platforms, you'll have this concept of bringing in the ABI, which is the interface so that our client side here knows more information about that, and being able to pass in arbitrary params that are needed for the specifics of your function name. And then up here is the way to construct all the parameters passed in. So to learn more about this, do check out docs.moralis.io and see the way that it's set up there. Now let's run the example scene again and take a look. So here again, we have information at the top about run contract function. That's the one that we're going to be calling. And then due to the fact that I have an actual contract deployed on the Mumbai network and I'm making live contact to that here in this demo, each time I click run contract, we get that info. It's the same info and it's quite simple info, but you can imagine in more robust examples or in your game project, you can have all sorts of functionality divided between your game client and running on the contract on the blockchain. That's it. And now let's take a look at the storage options we have here with Moralis. So in this example, we're using IPFS, which is the way that you're able to do storage with blockchain technology. And it's all exposed by the Moralis Web3 API. So here in the folder, we've got the scene itself. We've got, of course, the main script that we'll step through. And then I have an image here, which I just created as a test image. What we're going to be doing is running this scene. We'll upload this to IPFS and then be able to fetch it live from IPS and render it in the UI. Now, IPFS can be used for storing all sorts of things, and you want to look at docs.moralis.io to learn more about IPFS and Moralis' implementation of it. But you can certainly store other things other than images, but an image is a great visual, quick example here, so that's why we're using it. So let's go ahead and run the scene. Now, as it first loaded up, it automatically saved the image, mimicking the Save Image button at the bottom. You can see at the top of the screen a little info about the API call itself, and then at the bottom, information about the parameters that I sent. So I chose this particular path, and I used that local image that I mentioned. That path is where it's being stored up on IPFS itself. And just to confirm that some information went through, I'm showing the content length here as well. That's not really an important detail, but just the fact that it's non-zero helps us understand that something went through in the content. So we are able to load the image here by clicking that again. We're able to save the image. That takes a little bit longer, and then it renders it out. And we're able to clear the image. Now, what I've done to clear the image here is I actually upload just a gray box. So it's not actually deleting from IPFS. It's just overwriting the same path with a content length of 0, you can see. And Unity chooses to render that as a gray box there. So you have something like being able to save, load, and clear. Now let's take a look at the code for that. So here in the code, again, you do want to go check out docs.moralis.io for more information about IPFS and the setup involved. And because Moralis here is using the existing technology of IPFS, you're somewhat limited and you get all the great features of that IPFS system. So you want to learn more about that. Now in the upload, when we click the upload button, what we do here is we describe a request, which as I mentioned before is going to be a path and some content. I've used custom code for the example's sake to convert an image inside Unity into a content byte string. So you can take a look at the code and how I did that. For your own needs, you're going to want to solve that. The content could be text or images or sound or whatever, any kind of format that works for you. Here we're using an image. And then you can see where that request is used here. Down here, we're able to call the Web3 API's storage upload folder. And the signature of the method hints that you might want to be uploading more than one piece of information. So the API we always use is upload folder, and we pass in a list of requests. So I'm only uploading one file at a time. So my list has exactly one request, but you can imagine in a more robust application, you would be loading and saving imagery or videos or other types of media, text, etc. in batches with multiple. You're able to do that as well. So that's it there. I go ahead and I load that up, and then I render that out to the screen inside the UI file. Let's run the scene again and take a look. So here again, as it loads up on its own, it automatically does the load image, and we're able to load again. We're able to save again. Saving takes a little bit more time, so you can see that there's a delay each time I click save. And then we're able to clear. Remembering that clear is essentially a save, so it's just either saving with the imagery, or when I hit clear, it's saving with a blank image, which is somewhat analogous to being able to clear out or delete information. That's it. Web3 client examples. Next, let's take a look at the Web3 client. Now here we have one demo to take a look at, which is send transaction async. So inside the folder here, we see we've got the scene itself, and we've got the mono behavior that runs behind it. We'll take a look at that. I'm going to run this scene, but a caveat here is that this demo is purposely limited in its use because this is going to require some signing operations. So you're going to want to choose the parameters that work best for you, and you can go ahead and paste them into the scene here and run it on your own when you download the project. We'll take a look at the code here. So what send transaction is able to do is send from an address to an address. Let's look at the code. Okay, so here in the code, again, you want to check out docs.moralis.io on this one to understand more about how it's used. We can take a look. So what I've chosen to do for the sake of this demo is I have not populated sample values here. So if you have your own from address and to address that you want to transfer currency between, you would be able to just populate these two values here, and you're automatically going to be sending one currency unit in there. The setup here is to pass in the transaction input, which is the different data from, to, and the value you're going to send. We've got some helper functions and things to help convert currencies as needed. And then down here, upon successful transaction, it will confirm that you indeed did send a certain amount of currency from one address to another address, and it'll send back some info there. Let's go ahead and run the demo one more time. There you go, you can see. And you would be able to do that transfer each time you click it. You can, of course, set up your own addresses, download this demo, and give it a try, and see that that succeeds for you on your end, and then decide how that would be best implemented in your game project. That's it. Now you can level up your Web3 development skills by building weekly projects. With moralis.io/projects, you'll be able to build weekly projects, often launched on the weekends, win NFTs for your participation. Now, if this type of web content is exciting for you, like and subscribe to videos so you won't miss out on other free content in the future. So what's next with this examples project? Over time, this project will be updated and expanded. It will mature as the SDK itself matures. Let's recap. We've seen that Moralis provides a single workflow for building high-performance dapps. It's fully compatible with your favorite Web3 tools and services. Unity's flexible development platform offers incredible possibilities for real-time solutions, including games. And the Web3 Unity SDK brings the power of Moralis to your Unity projects. And the Examples project is a great way to learn more. It's a suite of Unity example scenes that showcase key features of the Web3 Unity SDK. Visit docs.moralis.io to download and get started. Thanks!